Woodworking machines revolutionize craftsmanship with unmatched power and precision. From robust table saws and high-speed planers to versatile CNC routers and heavy-duty jointers, these tools streamline cutting, shaping, and finishing. Designed for efficiency, they empower woodworkers to tackle complex projects with ease, delivering professional-grade results every time. Introduction to manual firewood processing machines. Manual firewood processing machines are tools or equipment designed to assist in cutting, splitting, and sometimes stacking firewood with significant human input. These machines typically rely on manual operation or minimal mechanization, requiring the operator to physically handle logs, position them, and activate the machine's functions. Examples include manual log splitters, hand-operated saws, and basic hydraulic splitters powered by foot or hand pumps. They are often used by homeowners, small-scale firewood producers, or hobbyists who process wood for personal use or small businesses. Manual machines are characterized by their simplicity, affordability, and reliance on human effort. Unlike industrial processes, they do not integrate multiple processes, cutting, splitting, conveying, into a single operating system. Instead, they focus on one or two tasks, such as splitting and require the operator to move logs between stages manually. This section explores the mechanics, applications, advantages, and limitations of manual firewood processing machines, providing a foundation for comparison with industrial counterparts in Part 2. Mechanics and functionality. Manual firewood processing machines come in various forms, each designed for specific tasks. Manual log splitters. These are the most common manual machines, using a wedge and ram mechanism to split logs. The operator places a log on the splitter bed and activates the splitting action via a lever, foot pedal, or hand pump. Hydraulic manual splitters use a small hydraulic system, often powered by hand or foot, to generate splitting force. For example, a 10-ton manual hydraulic splitter can split logs up to 18 inches in diameter. Hand-operated saws. These include bow saws, crosscut saws, or chainsaws used manually to cut logs into rounds. While chainsaws may use gasoline or electricity, their operation is entirely manual, requiring the operator to guide the blade through the wood. Manual wedge kits. These are simple splitting tools where the operator places a log on a splitting beam and strikes a wedge with a maul or hammer. They are low-cost but labor-intensive. Foot-operated hydraulic splitters. These use a foot pedal to activate a hydraulic cylinder, reducing upper body strain but still requiring significant physical effort. The functionality of these machines is straightforward. They assist in breaking down logs into manageable firewood pieces but rely on the operator's strength, precision, and endurance. For instance, a manual log splitter may take 10 to 20 seconds per split, depending on the operator's speed and the log's size, compared to 3 to 6 seconds for industrial processors. Applications of manual firewood processing machines. Manual machines are ideal for specific scenarios. Homeowners, individuals heating their homes with wood often use manual splitters to process small quantities of firewood, 1 to 5 cords per year. They are cost-effective for occasional use. Small-scale firewood businesses. Entrepreneurs selling firewood locally may use manual machines to keep initial investment low, processing 10 to 20 cords annually. Off-grid or remote locations. In areas without reliable electricity or fuel, manual machines are practical due to their independence from external power sources. Hobbyists and traditionalists. Some users prefer manual methods for the physical exercise or to maintain traditional woodworking skills. These machines are best suited for processing smaller logs, up to 18 to 20 inches in diameter, and shorter lengths, 8 to 10 feet, as larger logs require more force and effort than manual systems can efficiently provide. Advantages of manual firewood processing machines. Affordability. Manual machines are significantly cheaper than industrial.
I like that it doesn't shoot it all over the yard.
Industrial processors. A basic manual log splitter costs $100 to $500, while a high-end industrial processor can range from $10,000 to $60,000. This makes manual machines accessible to individuals and small businesses with limited budgets. Low maintenance, with fewer moving parts and no complex hydraulic or electronic systems, manual machines require minimal maintenance. Cleaning, sharpening blades, and occasional lubrication are typically sufficient. Portability. Many manual machines are lightweight, 50 to 200 pounds, and compact, allowing easy transport to different sites. For example, a manual splitter can be carried in a pickup truck or towed with an ATV. No power dependency. Manual machines operate without electricity, gasoline, or diesel, making them ideal for remote locations or during power outages. This also eliminates fuel costs. Simplicity. The straightforward design means minimal training is needed. Most users can operate a manual splitter or saw after basic instructions. Environmental impact. Manual machines produce no emissions and have a smaller ecological footprint compared to industrial processors, which rely on fossil fuels or electricity. Safety. While not without risks, manual machines generally have fewer automated components, reducing the chance of mechanical failure or accidents due to complex systems. Two-hand operation and basic guards enhance safety. Exercise benefit. For some users, the physical effort required is a positive aspect, providing a form of exercise and engagement with the task. Disadvantages of manual firewood processing machines. Labor-intensive. Manual machines require significant physical effort, leading to fatigue, especially when processing large volumes. Splitting 1 cord of wood, 128 cubic feet, can take hours or days, depending on the operator's stamina. Low productivity. Output is limited by human speed and endurance. A manual splitter may process 0.1 to 0.5 cords per hour, compared to 1 to 6 cords per hour for industrial processors. This makes manual machines impractical for commercial-scale operations. Limited capacity. Manual machines are designed for smaller lugs and cannot handle large diameter, over 20 inches, or long lugs, over 10 feet, efficiently. This restricts their use in diverse applications. Inconsistency. The quality and size of split firewood depend on the operator's skill, leading to uneven pieces that may require additional processing. Physical risk. Repetitive motions, heavy lifting, and potential for blade-related injuries pose risks, especially for inexperienced users. Back strain and fatigue are common. Time-consuming. Each step, cutting, splitting, stacking, is performed separately, increasing overall processing time compared to integrated industrial systems. Scalability issues. Manual machines are not suitable for scaling up production. As demand grows, users must invest in more advanced equipment, negating initial cost savings. Weather dependency. Operating manual machines in adverse weather, rain, extreme cold, can be challenging, as they often lack protective cabs or ergonomic features found in industrial models. Case studies and real-world applications. To illustrate the practical use of manual firewood processing machines, consider the following scenarios. Case Study 1. Rural homeowner. John, a homeowner in Vermont, heats his home with 3 cords of firewood annually. He uses a $200 manual hydraulic log splitter to process logs from his 5-acre woodlot. The splitter handles logs up to 16 inches in diameter, and John spends 2 to 3 weekends per year processing wood. The low cost and simplicity suit his needs, but he finds the process tiring and time-consuming, especially for larger logs. Case Study 2. Small firewood business. Sarah. Effective and practical for small-scale use but struggle with efficiency and scalability. Technological and design considerations. Manual firewood processing machines have evolved to improve user experience while maintaining simplicity. Ergonomic design. Some splitters feature adjustable handles or foot pedals to reduce strain. For example, vertical splitters allow users to work at a comfortable height. Material quality. High-strength steel wedges and reinforced frames enhance durability, allowing manual machines to handle hardwoods like oak or maple. Safety features. Basic guards, 2-hand controls, and non-slip surfaces reduce accident risks. However, these are less comprehensive than industrial machine safety systems. Portability enhancements. Wheels, tow hitches, or foldable designs make manual machines easier to move, though they lack the mobility of trailer-mounted industrial processors. Despite these advancements, manual machines remain limited by their reliance on human power, which caps their efficiency and output. Economic and environmental impact. Economically, manual machines offer a low entry barrier, making firewood processing accessible to a wide audience. They support small-scale economies by enabling individuals to produce firewood for personal use or local sale without significant investment. However, their low productivity limits profitability for commercial ventures. Environmentally, manual machines are eco-friendly due to their lack of fuel consumption and emissions. They align with sustainable practices by allowing users to process locally sourced wood, reducing transportation impacts. However, their inefficiency may lead to higher overall wood consumption if users cannot process enough firewood to meet demand, potentially offsetting environmental benefits. Future trends for manual firewood processing machines. The future of manual machines lies in balancing affordability with improved efficiency. Hybrid designs. Some manufacturers are developing hybrid manual hydraulic systems that use minimal electric or battery power to assist with splitting, reducing physical effort without the complexity of industrial processors. Lightweight materials. Advances in composite materials could make manual machines even more portable without sacrificing durability. Smart features. Basic sensors or gauges to monitor splitting force or log size could improve consistency, though these may increase costs. Rental models, as seen in some markets, renting manual machines for short-term use is gaining popularity, allowing users to access equipment without purchasing. These trends aim to address the limitations of manual machines while preserving their core advantages of affordability and simplicity. Introduction to industrial firewood processing machines. Industrial firewood processing machines, often called firewood processors, are advanced systems designed to automate and streamline the cutting, splitting, and sometimes stacking of firewood. These machines integrate multiple functions into a single unit, processing logs with minimal manual intervention. They are typically used by commercial firewood producers, forestry operations, and large-scale suppliers who need to process high volumes of wood, 50 to 500 cords annually. Brands like Timberwolf, Cord King, and Hacky Pilka dominate the market, offering models with outputs of 1 to 10 cords per hour.